So, very good morning to all my budding architects. Our esteemed speaker for today's session, Anupama Kuppam. It gives me immense pleasure to welcome you all today's a special talk on the architect's green blueprint, a roadmap to network zero, net zero, and green rating systems. We all know that in present time, rapid urbanization and climate change, architecture is no longer limited to design buildings only. It has become a powerful tool for creating a sustainable and environmentally responsible future. The concept of net zero buildings and green rating system is transforming the way architects think, design, and construct our built environment. These approaches emphasize energy efficiency, reduced carbon footprint, responsible resources, usability, and healthier environment. As future architects and professionals, as budding architects, understanding these principles is not only essential, but you will utilize to shape your design in upcoming time, to shape your cities, so that our city will be resilient, sustainable, and aligned with globally environmentally sustainable goals. Today's session aims to provide valuable insights into sustainable design strategies, the role of green building rating systems, how we all know that GRIHA, IGBC, ASOGEM, and these three are the Indian rating system, and LEED is the American rating system, green building rating system. So, on the behalf of Lovely School of Architecture and Design, Lovely Professional University, extend a warm welcome of our esteemed speaker, Anupama Kuppam, our proud alumni. Clap for Anupama Kuppam. With these words, I warmly welcome Anupama Kuppam, graduated from Lovely School of Architecture and Design, and presently, she is working as a senior architect exclusively for Lead Green Associate, Senior Architect, WSP, Bangalore, Karnataka. So, welcome, Anupma. We are feeling very proud that our alumni, our student, whom we have taught, and today we are inviting as a esteemed speaker. Welcome once again, and over to you.
Thank you so much, sir. All of you, very good morning. And with this start, I really feel like missing LPU. It had been great days. So let me introduce myself. This is Anupama. Uh, like sir said, working as an architect in WSP India. I have been working on majorly on industrial projects like substations, nuclear power plants, metro lines, etc. So if the more the building the more building is bigger, the need of green rating system increases because there are the amount of concrete or the amount of materials or the space we have to utilize became drastically more compared to a small residential building. So today we will be going through a roadmap to net zero and green rating systems, mainly covering two topics, which is just a second.
Moving ahead, Anupma.
Yes, yes, sir. I'm just checking if my screen is moving. I guess you can see, right? Yeah. Just give me 1 second so that I can keep my screen so that I can see the students also, PPT also. Yep. As I was saying, two topics. One is net zero, one is green rating systems. So you all have heard net zero, like from past 10 to 15 years, this have become a trend kind of thing. But did you ever thought like why it is called net zero? Why not just zero emissions, or just zero energy consumption or something? Why it is net zero? Is anyone interested to answer? Guys, let's make it more of a engagement session rather than I just going through presentation.
I want to suggest you, first of all, complete your presentation,
Yeah.
and then a student will come here and interact with you one by one.
Okay, okay, fine. Okay, let me answer it then. Uh, Net zero is something which is like, to say it in a word, it's like using no more resources than it can produce. For example, if I'm designing a solar panel, which is a renewable energy thing in my building. See, if I am able to create 50, some around 50,000 kilowatt, for example, and my building is consuming less than it or equal to it, not more than it, not 51, not 52, but less, somewhere around 45,000 kilowatt or something, my building comes under net zero energy. Likewise, one more thing is there, net zero carbon. So why carbon is so important now than any other thing in the world? I'll be explaining. Just let us go through the next slide. My first question is, what is the biggest problem on our climate? Many might have thought about it, right now on planet Earth, what is the biggest problem we have? It's climate change. That's the biggest problem we have. So what is the main cause of climate change? Everyone knows, because we have been studying it from since first class, second class, that is GHGs, greenhouse gas emissions, right? So out of GHGs, which is the major gas that is leading to these emissions? There are n type of gases like carbon dioxide or fluorides, etc., which is even causing trouble to ozone. But my main emission is CO2. So I'll tell you comparatively how much CO2 is, when compared to other gases. Carbon dioxide itself is releasing around 76% of emissions, and rest all like methane, nitrous, fluorinated gases, and other gases which are like in very I can say very minute quantities. uh, Coming to next slide, what is the source of this pollution? So there are, we came to know now 76% of this emissions are carbon. So what is the source of pollution? So the first source of pollution is 25%, which is like electricity and heat. Whatever substations we are using, HVAC we are using in the building, everything that comes under temperature control, electricity and heat. So the second most reason is agriculture. Okay, why I am telling agriculture is the cause of this crops, landfills, waste, and also deforestation. These all comes under agriculture. So we have been like studying that all throughout architecture, I believe. And next one is industry. Industry, what comes under industry is like oil and gas, some iron and steel production and extraction, and also this mining. I can say mining is like one of the major concerns under industry. And then transportation, which is like through all roadways, ships, or aviation, whatever is there, and other energy, food waste, and buildings. Buildings in the sense, I'm not counting on electricity, HVAC, and all, but only the construction and demolition part itself is causing 6.4%. It also adds on some thing called as VOCs, refrigerants which we are using, etc. Going to next slide. I'm sorry. History. Okay, when did our people realize it is important to count on net zero? So it started somewhere with the Kyoto Protocol, which is in like 1997. This is like a brief history from where we started and where we ended. Okay, they started with carbon neutrality. Carbon neutrality, I'll be talking about carbon neutrality. It is something similar to net zero but not net zero carbon. Why? Because in carbon neutrality we'll focus only on carbon. Whatever carbon emissions are done outside, we'll try to balance it. That's it. But when it comes to net zero, we'll count on carbons, we'll count on nitric acids, we count on other this sulfur, fluorine, and chlorine substances which we are releasing. Everything like all together like a package. That's where it differs between carbon neutrality and net zero. And then comes Paris Agreement. Like, how many of you know Paris Agreement? Like, this is like one of the I can say very important agreement which was made in history, which created a solid framework. It's more of like more than 197 198 nations. They came together, they made an agreement that they are gonna limit the global warming to 1.5 degrees, not more than it. That is what was decided in Paris Agreement. So why these nations like India or like America, UK, all are behind this carbon control and net zero emissions? The main cause is this Paris Agreement. Until there is something on paper, no one will initiate something solid. So this is one of the agreement. So you can go through it, it's very interesting. And then comes national targets. I can say that Sweden became the first nation to enshrine a net zero target in law in 2017. So there are some there are some industrialized countries, and there are some developing countries, right? So Sweden already targeted net zero by 2017 and by 2019, but some other countries and one more thing, Sweden, Norway, whatever these countries are, they have very good advantage of their Nordics temperature. Okay, they have very low temperature when compared to countries which are near to equator. So it's, I can kind of say it's a little easy for them to make it. And then comes UK. UK had targeted, because UK is already developed, they build their houses. You see, maximum of UK projects we do are renovation, but not new buildings. If we get 100 projects, out of which 80 will be renovation and for renovation, and only 20 projects will be for new construction phase. So UK is also targeting net zero by 2050. And recently there is this COP26, like national framework. You might have heard like every 1 year, 2 years, somewhere this United Nations gatherings will happen, and they will talk about climate change. They will talk about the nation's framework and whatever laws they have to introduce in their countries. Like that, India had announced its target to achieve net zero by 2070 at this 26th session of COP26. This was in 2021. Coming to next, this is about like brief history. Coming to global net zero targets. I already told. If you can see the map, this started with 2010, right? So this is the time where we are like drastically like increase, like the amount of carbon emissions had been increased. So we want, the plan is like we want to reduce it and bring down to zero by 2050. And then more, we want to achieve carbon negativity, where like carbon emissions is there, and carbon neutrality is there, where I'm balancing my carbon. And there is something called as carbon negativity, where I know I won't emit any carbon, and also I will do something positive to the environment, which will create some carbon negativity. I'll be giving a brief of it in coming slides also. So, scope of emissions. So, this is very important when you're planning something for net zero. So, there are three types of scopes. One is like scope one, which is direct emissions. Scope two, indirectly electricity emissions. Scope three, value chain emissions. Scope one or scope two are easy. to manage, or easy to put some benchmarks and ask some company or some building owners or someone to follow. But scope 3 is something very like, I can say, high level targets, where until or unless you reach scope 3 you won't be able to achieve a net zero building. So scope 1, like direct emissions, like fuel use in vehicles, boilers, industrial process, like suppose few of my projects I have worked on, like substations and all. So there are situations where the complete energy whatever being inside that substation is 100% renewable. Okay, so they are not using any diesel generators or something. So that is like that comes under direct emissions. So scope 2 is indirect electricity emissions. See, I have a building, okay, where I control my direct emissions, okay, and I have to control indirect electricity emissions, that is not coming directly through my building but coming somewhere else. I want to reduce that so that I can balance my carbon emissions. See, there are a few cases where we can't avoid things, like for example HVAC. There is one office, nice office buildings with all glass walls and everything, it's completely sealed. A building is sealed. Can you avoid giving a air conditioning inside? You have to, because there is no other options. That is what client need. So in that cases, how you will reduce your carbon emissions, because you are already got a approval that you have to use AC. So in that case, what I'll do is I will purchase electricity, renewable energy, electricity from some solar farm or some wind farm or somewhere. So how much ever I am emitting, for suppose I have emitted like some 10 tons of carbon emissions. So how much ever 10 electricity, the 10 tons or save, that much electricity I'll purchase from that farm for free, so that I can use it, or I can give the grid, the government grid can use it, I can sell it, whatever I do, but I have purchased and offsetted my carbon. And then comes scope 3. Scope 3 is like very like chain emissions. For example, I can say waste management. So every day like any kind of building will produce some waste. So normal practice is to send all that waste through municipality, and then they taking to their warehouse, like whatever they do next we don't know. But some companies, what they do is they will make sure of what is being done to this waste, how they are being recalcinated, how they are being buried, and then carbon emissions or not, carbon is not getting emitted from it. So this is something a kind of a personal decision with which a owner of the building or owner of the company, or the what I can say, the client have to take. So these are three types of scopes. I guess you all are clear with the three types of emissions where we can achieve net zero. There are two paths for achieving net zero. One is reduce scope 1 and scope 2, and scope 3 offset residuals with verified carbon removal. This is not yet in India, I can say. Few places like which are like where we have lead certified buildings like cyber city in Gurgaon, etc., they started doing it, but it's not that much active in India as of now. Coming to next, so we have talked a lot about carbon emissions. So let me tell you how many types of carbon emissions are there in entire life cycle of a building. So there are two types basically. One is embodied carbon, one is operational carbon. What is the difference between these? Embodied is what comes with the material, like raw material extraction, transport, manufacturing, and all. Operational carbon is when a building is ready and you're using lot of HVAC systems, lighting systems, like if it is a office, a building or something, you are using lot of PZs and all. So these all comes under operational carbon. Due to use of these things, how much carbon is emitted during the life cycle of the building comes under operational carbon. So this is like whole life cycle. Like when you are free, just go through this map. This is really helpful if you can read it once. As an architect, what are the stages which are important for us? Let me start with extraction of raw materials. This comes under embodied. Okay, somewhere, for example, I decided that I want a marble for my home which is from Rajasthan. Okay, in Rajasthan, to extract this marble, they are using lot of equipment, lot of vehicles which is releasing carbon that comes under embodied, and then transport to factory. From that mine, it is being exported to factory to make it perfect, shaping it or like polishing it, whatever it may be. It have to be taken to the factory for the transport. Again, my vehicle is releasing carbon, and then after taking to the manufacturer unit, again they are using missions and oil to make this products perfect. And then once product is ready, I have to import it to the construction of where the construction is happening. Again, I'm releasing some carbon, and then comes the main usage of buildings. Till here, whatever is released is embodied. So this is what we can't control except with choices. So next one is the use and maintain the building. So this is the only one where operating carbon comes in place. So let's not talk about our operational carbon, which includes like many points. I'll be coming in like I'll be telling you in upcoming slides. Once the building lifetime is over, we will be demolishing it again. So that also involves in some equipment, and also that waste materials have to be hauled away. That also consumes. And then landfill, the recycling process also will emit carbon. Once after recycled, if I decided to use some salvaged materials or like reuse the materials, again it comes to extraction of raw materials. So this process keeps on going. So as an architect, it is very important to know all these timelines and choose materials based on how much ever you can reduce the carbon emissions. So I was talking about carbon neutral, right? So this is like a image which will give you a good idea of what carbon neutral is, what net zero is. Net zero includes everything, as I said, but carbon neutral is only how much ever carbon I'm releasing, that much ever carbon I'm saving by planting trees, by doing deforestation, by purchasing renewable energy. Whatever I do, I'm just balancing carbon, but not other things. Whereas net zero covers everything. So this is very good example. Uh, like it's in Maryland, USA, where they have used photovoltaic systems, geothermal wells. You can see like how deep they have gone to maintain the temperature, and high performance electromagnetic envelope, earth coupled heating and cooling system, and thermal pool. So this building have a lot of solar panels. So it's like almost 3000 solar panels where it sells more power than it buys. So I told you that whatever we are using, if we can produce more than it, building can produce more than it, obviously it comes under net zero. And then there is one good example in India, which is like Indira Parvayana Bhavan in Ministry of Environment and Forest, Delhi. So this is also kind of first net zero building constructed in 2014. You can see in the images how nicely they have used stack effect and cross ventilation techniques, and the detailed building envelope. This particular topic, building envelope, is gonna be important to us because we are gonna do a fun exercise on it. So see how they have used UPVC windows, high efficiency glass, high reflectance terrace tiles, etc. When you get the presentation, you can just go through these two buildings. They are like very good example. So something about net zero. Now you have very good idea of what is net zero. Now how you will achieve net zero. This is through something green rating systems. Why green rating systems? See, we all studied architecture, right? There are people who haven't studied architecture by degree but also practicing in the market. What is the difference? So your teachers, your faculties have framed a syllabus, your university have framed a syllabus, and they have sent benchmarks for you what you have to learn every year, every semester, and made you perfect as an architect and send out of the university, right? If you don't have that knowledge or that roadmap, would you be able to be that efficient? No. Same thing, if I want my building to be a green rated, there are some fundamentals and benchmarks set it by government, s- uh, 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 and sometimes private also. So these are called as green rating systems. So I'll start with 5 W's: what, when, why, where, which. After these 5 questions, lot of the questions which you lot might be having about green rating systems might be clear. First, we'll start with what. What is a green rating system? It is a framework where to reduce the impact on environment is the first priority. So you all know the three pillars of sustainability, right? Like the triple bottom line, like environment, social, and economic. These three are primary things when we talk about green rating systems. Anything we do in relation with green rating systems, we do for either economy, environment, and social. By definition, this is what green rating system is. There are n number of green rating systems like IGBC, Griha, LEED, Well, BREEAM, so many. But the language which all of these green building rating systems use is same. Everything. When you start with ECBC, go to LEED, the topics which you have to cover is same. First one being location and site. What, like how you are selecting your site, what constraint did you consider while selecting the site, what is the location, what is the temperature, something you might be doing as a site analysis, right? And next one is water efficiency. If it is if my building is somewhere in a deserted area, or somewhere water is not much, like plentifully available, I have to be I have to be reaching high benchmarks in water efficiency. Next one is energy conservation. This comes under all HVAC, lighting, your equipments, whatever systems, everything you are using inside a building, from uh, fan to a plug point. And then comes materials. Materials is very important thing in present day. Anyone heard of EPDs? EPDs are environmental product declaration. Every time you purchase a material from outside, so when I'm designing, it's easy for me to say, okay, I'm using this insulation, this foam insulation, this will help me. But how far it is helping me, how do you know it? So there comes EPDs. EPD is a report or a certificate of a material where they have considered life cycle of the material from raw material extraction to the operations, where how much it will affect the health of humans who are residing in that building. So EPDs are always important. As much as you can choose materials with EPDs, that much sustainable your building will become. And then comes indoor environmental quality, and then innovation. Innovation is an optional credit in all rating systems, even in IGBC, even in a LEED. See, because they don't want to limit your creativity and your opportunities by these chapters which they have already listed. You might be having some other idea, you might be introducing something new in the market. That's where innovation comes in. So when to use it? When do we require green rating systems? I can say the 70% we will be using green rating system through pre-design and design stage. This is where you have to choose right choices for your building by studying green rating systems. So once this stage is crossed, when I came to construction stage, there is no go back. If I see that something is not doing well, this insulation is not efficient for my building, I can't go back. I have to remove all those and then again install it, which will increase the cost eventually. So pre-design or design is very important stage, are a very important stages for architects. And then I won't say that construction it's not completely avoidable. Like when construction is happening, to maintain the health and safety of workers, also green rating systems have some requirement. And then commissioning, testing and verification, whatever was done in pre-design, design and construction, they have to be tested and verified, or else it's just on paper and there is no proof for it. So there will be testing and verification with both IGBC and LEED and any other renowned green rating systems. And then comes operation. During operation, it is an optional thing. When it comes to LEED, there are two things, like different versions. One is new building version, one is operations version, so where you will focus only on operations on building but none of the previous stages. So that also is an important stage. And then why we are using it. So why green building rating systems are important. The answer is first one, climate goals. Have anyone heard of SDGs, sustainable development goals? There are like 17 sustainable development goals which we are targeting and all nations are targeting. So the first priority is climate goals, and then comes health and safety, who is residing in the building. And then resource efficiency. We always know like what sustainability is, not to compromise the needs of future. So resource efficiency is also a key aspect. And then minimize environmental impact, and then ensure compliance and accountability. When it comes to compliance, see, some places had already made green rating systems mandatory. It's not an optional anymore. For example, I recently came to know that Andhra Pradesh had made ECBC as mandatory thing for sites which are more than 2000 square meter. So something like that, like one by one the states and nations are coming friend to make it mandatory, and where they are used. So mainly in built environment where we all are working. And then comes the urban infrastructure, not only buildings but also bridges, highways, where tons and tons of concrete is being used. There also it comes in place. Public and institutional, environmental and policy, like ESG goals, I told you, like economic, social, and governance goals. And then business needs. So the main question is which rating system you should use. There are n number of systems, which one to be used. The answer is, if you are working on a government project, go for griha or IGBC in India. And if you're going for a corporate or global client where there is no restriction of uh, cost or something, go for LEED. This is like a premium version. And then private Indian developers, they can also go for LEED. And then energy code compliance, which is like very important. Even IGBC and all, there is something called as ECBC, Energy Consumption Building Code. Okay, even IGBC use reference of ECBC to meet energy goals. So if you are focusing only on energy but not any other aspects, go for ECBC. And then occupant health focus. The health is primarily considered in well, and also there is something called as BRIAM. BRIAM is just like LEED, how it is official rating system for US region. BRIAM is officially a rating system for UK region, England region. So that is also gives very good occupant health focus. And then comes net zero and climate goals. All these versions have a net zero version. And then let's conclude the presentation with commitment to sustainability, adopting green strategy, and leveraging rating systems. Before, we don't know like where to start and where to end to make a building sustainable. Now you have n number of systems in your hand, n number of options. You have good faculty to teach you. So just leverage these all benefits which you have. So that's all about the presentation. If any doubts, you can post or you can come and ask, and we will be continuing with one assignment which is fun and interesting as well. Anyone?
Yes, Anupama. So wonderful presentation. So can you share that PDF you have already shared
Yes, sir. I have
regarding
already
the
shared. Should
class?
I share in
You will
this
just
chat box?
yes, yes, yes. So you will just show here and instruct to our students, your juniors.
Okay.
Please.
Sir, for some reason I'm not able to attach it in the chat box. I'm not getting that
I
admin
have
permission.
already shared with student.
Okay. So everyone have it, right, sir?
Yes,
Okay.
everyone have this PDF. I am just saying to you, you will just, if possible, you will show it on the screen and instruct
Yes.
to the student.
Sure, sir. So let me share the. I have shared this PDF, which is of 5 pages. Okay. So this is a part of ECBC rating system copy. Okay, where you have a type of materials, and then the density, thermal conductivity, and specific heat of materials was given. So mainly these materials are from India. There are almost like 4 pages of materials, and in last page I have given you a map to know which climate region that particular place is. So I have got your design brief where people are working on Noida project with Modark. So I want these people who are working on this project to choose their own design project, but other people who are from other the final year or something can choose any place you want in India. The type of climate is there. Just note down the area and then what climate type it is. And then I have already also shared with you one website. This is the one. So this is U value calculator website. Now I'll explain what the assignment is. So listen to it, guys. Let me share my screen of this again. So why this assignment is chosen? Because see, the primary aspect of all out of all these things which a green rating system have is energy conservation. So energy conservation is like ultimately high preference when compared to other things. So let us do a short exercise on energy conservation through building envelope design. Whatever your building is, there will be an envelope to save it from climate or to save it from weather. So these envelope have some particular elements, which is roof, wall, doors and windows and all. So how do you design these walls? Like how do you know that this wall will suffice me if my building is in Rajasthan? How do you do it? So first let me explain what thermal conductivity is, and then we go for how do we do that. Thermal conductivity is mm, I can say something which we are learning from conductivity and all, we are learning from first second class science subject. So where it is just heat transfer from one side to other side. So there is a wall of my building, there is sun coming, and there is some temperature being created here. How much of it is going that side? How much of it is my material absorbing and sending on inside my house is something known as thermal conductivity. And then comes thermal resistance. Thermal resistance is something which says how much of energy my material can absorb inside, not to send inside, but absorb and reflect, resist itself. And then comes thermal efficiency. This is like a combination of thermal conductivity, thermal resistance after resisting itself and after giving a specific amount of heat, throwing specific amount of heat inside. That heat inside my building, how much efficiency it can create is something called as thermal efficiency, which is also known as U value. When we talk about U values and V values, this is it. This is regarding thermal efficiency. So what I want you to do is just wherever, whatever climate you have chosen, try to design a wall, a building envelope of your project by choosing materials by layers. For example, I'll tell. For suppose I have chosen my site in somewhere Rajasthan, end of Rajasthan. So it comes under hot and dry climate. Okay. So in hot and dry climate, what do I think of? How much insulation I should give? So let me start with some cladding material. Let me start with some particle board material, and then goes plaster, and then goes some insulation. Choose the material from here. You are free to choose from online as well, but the thing is, you should have thermal conductivity value. If you ask AI, maybe it can give it easily, but choose the materials here, make layers and make a wall. These layers where you have to do here, every time you are choosing a material, for suppose I'm choosing a plaster board, for example, I'll add a layer, I'll tell it plaster board, and then thickness of the material. You all know thickness, like normal thickness which is available outside. For example, I'm choosing it like 20 of plaster board material, and then thermal conductivity where you will get from this. Choose where is the plaster board, where is the plaster board. You just search for it and then get the thermal conductivity value. For example, thermal conductivity value, just paste it here. Okay, add layer. Like this, I want you to prepare layers of a complete wall of your project which you are suggesting as an architect. Any doubts? Is it clear?
Any student want to say something? Any problem? Saying no, no.
Yes, sir. Okay, guys, just do this exercise. Later on, I will tell you if your whatever wall you have designed is meeting the sustainability or not, how to know it. So from now on, you won't get a question of what material to use.
Anupama, now we will start the interaction session.
Yes, sir, we can go do that parallelly, and in
Yes,
10 minutes,
yes,
maybe, yeah, students can make this assignment also.
right, right. Yes.
Guys, let's make it 10 minutes. So you'll get 10 minutes to design your wall. You only need three things. What is the material? What is the thickness of material? What is K value? Okay.
Okay, so Anupma, students are coming one by one. Okay,
Yeah, please.
interested students are coming for interaction. Okay.
Yep.
Yes, Khushi Thakur from fourth year. Clap for Khushi. Yes. Taran Sharma from fourth year. Yes, please.
Hi, Dee. Nice to meet you. Yeah.
Hi. Glad to.
I just wanted to ask you, like, as there is like insulation also there provided and everything, how do we naturally decide? Like, our site is in Noida right now, which is composite climate. So, how will we decide whether to use a rock wool or polyethylene? And I have seen like there are different types of it, like hard and like I don't know ki if I want to put a sandstone, for example. So, how to clad it exactly? Like, I have no information about it. Like, I don't know how to do it.
Guys, you are in AI generation. So, see, uh, if you need information about what all layering you have to do, you can always give the material name and get the data from AI. That's the easiest thing you can do in present day. One more thing, to know what material you should start from, like that knowledge comes from your architecture background. Okay, normal person don't know where to use insulation, where not to use insulation, but you know well why to use insulation. And third question comes, which type of insulation, like rock wool or whatever you are asking, which type of insulation will suit. So by the assignment which we are doing now, you will definitely get answer after this assignment which one to use.
Mhm.
Okay, so just
Okay,
just
then I'll carry on. Yeah.
yeah, please just do this. You'll definitely know from now on, whatever building you design, whatever wall you are creating, you will have a solid proof of why. Yeah.
Okay, we'll do that. Yeah. Thank
Thank you,
you.
Kushi.
Thank you, Anupma.
Thank you, sir.
Now, Pragya Panda, come here. Yes. Shanmati. Yes, Shanmati, come here.
These are volunteering themselves, sir, or you're calling them?
All right, come.
Yeah.
Yes.
Hello, ma'am. I'm
Hi.
Shanmati and I'm from Tamil Nadu. And the question I have is like, what type of software that I can use to simulate all the materials that they would give in app?
Seema, there is no software such as available for free, I can say. And you have to know the difference between architect and simulator. So architect only designs what and decides what is needed. And when it's come to simulation, there is someone called as sustainable consultant or someone who have this license of software. You, I will suggest you not to go for any software such as there is something called as, I guess, Tolo or Tolly something. Tolly. Okay, there is something called as Tolly. Okay, which is not that much accurate, but will give what you need. Instead of it, go for AI. Instead of going for softwares, go for AI. You'll get a better result. This is what we have been doing as an architect instead of directly approaching a sustainable consultant or someone. Yeah.
Thank you so much.
Welcome.
So now next student, Amrita Varshni from 5th year.
Good morning, ma'am. Hi.
Hi, good morning.
So for my final thesis, I'm doing a project that has required me to meet VIHA standards. So, like you said, there is no software to actually just assess the materials, but I've already learned about the materials that I need and the U values that I need to achieve according to ECBC, because I'm also looking at um, meeting the ECBC Super Plus requirements for my building. So, I was just wondering, how would you kind of recommend me going about integrating the materials, because I know the materials, but I'm kind of conflicted between giving it the needed strength but also meeting the green standards.
Okay, got it. First thing is, it's really good that you're using ECBC and that too you're going for premium level for your thesis project. So, Seema, before ACBC or before how much energy I am able to save through my the properties of material, the first question is where it is coming from. So I would suggest you to search for very good companies or very famous companies in India. For example, Tata have n type of material. When it comes to glass or something, you may go for Saint Gobain, for example. Go for really good things, and then you get those technical specification of their materials. If you don't get it online, just call them directly and just ask for a technical specification. You will get the values in your hand. You have ECBC report. You just tally which one is like suiting as per my premium level ECBC certification, right? So for suppose if you go for glass, there is something called as SHGC value, solar heat gain coefficient value. So you already know for your climate region you need your SHGC somewhere between zero point 0.5 and zero point 0.6. So you already got a technical specification or all type of glass from Saint Gobain, a PDF. So you have to choose the materials which are okay falling under this category. And then comes the second thing: out of all these materials which you have listed, see which one is low cost, and then just apply the material. That's it.
Thank you.
Welcome.
Yes, that's all I had.
Yeah.
Who is the next? Yes, Pragya Panda for 4th year. Yes, come. One more student from backside. Yagi ji, okay. Pragya, come fastly. So interaction is very important, Anupama.
Yes, sir. I agree.
Yes, who is coming? Yes, yes. Our assistant professor, Priyadarshini Chaturvedi ma'am, she want to ask question.
Yeah, hi Anupama, how are you?
Hi, Priyadarshini. I'm good. Thanks for asking.
Yeah, I have a question. As you're a lead associate and IGBC accredited professional, so can you help with if somebody wants to apply or get a certification for lead or as a IGBC professional? So how can they approach for it?
Okay. Uh, First thing is, there are this lead accredited professionals and IGBC accredited professionals. So the first thing is to aim or meet someone who is IGBC AP, who is very well thorough with the process. And they will be as a project manager for entire process, because there are n number of series and n number of policies which have to be followed under IGBC and also lead. So, first thing is, when your building is in pre-design stage, there are two things. One is approaching these organization during pre-design stage. One is like post-design stage. So it's your choice when to choose, when to approach them. So you have to approach with your design, apply online. For lead, there is a website called Lead Online, where you have to register your project. Here is my project, these are the documents of my project, this is the area of my project, everything. You have to register your process, and then you have to choose what you're aiming for the lead building, a new building construction or operations, or it's a neighborhood or it's a residential building, whatever it is. You have to choose what I am targeting. If it is for IGBC, it is like platinum rated or gold rated, silver rated. You have to choose what you're targeting. And then IGBC and lead both have this guides, right? So in that guides, they have chapters, how the points can be achieved. Each chapter will be consisting of few points, like 10 to 15 points, somewhere around. So if you have to get IGBC platinum, maybe you have to choose above 90 points. So you have to choose in which category I can choose. Oh, water efficiency, okay, I am having very like plenty of very less water, so let me propose a water harvesting or something, I can get a point. Something like this, you have to make decisions. And once all these points are compiled and submitted to the organization, they will come back with comments whether this is okay, this is not. If something is not good, okay, are you able to change it, or are you able to transfer to any other credit inside? They will be suggesting you. Once everything is done, okay, your credits are finalized after second review, then comes your certification. Whatever platinum certification you will get, silver certification you will get, something like this. So the
So,
primary thing is points. Yeah.
so do we have to create any prototype or something for it?
I You don't have to in maximum cases, because they just need proofs for whatever points you are choosing. So if you are choosing points for building envelope, for example, I'll say, so obviously you have to give some calculations. You don't have to build a 3D or something kind of thing and then give, but you should have calculations with your material, a solid proof for them. Yes, okay, you are targeting this. It's just based
Okay,
on proof.
okay. So if we have a certain building, okay, we have designed a certain building and I wanted to convert or I wanted to have a LEED certification of that building. So so that it can be energy efficient. So like how can we do that? Because we have a building, we have already built or developed a building which is already there, but we wanted to have a LEED certification for that building so that it can be recognized as a energy efficient building. Like it should fulfill certain criteria of energy efficiency. So how can we bring that? Because right now we have graduation students who will be graduating, so they do not have that idea of how they can achieve the principles or qualities like we have in an energy efficient building. Okay, so that we can go for a LEED certification or GRIHA certification, whatever. So how can we do that?
Okay. Let me give a glimpse of something for your question.
Yes.
Yeah.
Guys, he will be showing that if you have a building and you want to convert that to building. Okay. So she will show you some games. बेटा जिसको नहीं देखना
Just give me a second. I'm getting the file. Yep. I'm not able to share my screen actually. Disable share. Can you please enable it? Mm,
No, it's already been there. It's already
mm,
been allowed. Is it not allowed or it's already been allowed?
host disabled attendee screen sharing, something like that. It's coming. It's okay, no problem. Then I will be sending one website, okay,
Okay.
and a snip of for lead I am talking about. For lead, the building construction, a new building construction, and yes, I'm not even able to paste it.
So is it now being possible to share it? No.
Let me check, Priya. Yes, I guess yes. I don't think so. Am I audible at all?
Your video is stuck at one.
Yeah, when I'm trying to share, it's not allowing me to. Okay, it's okay. Fine. Let me tell you that especially for lead, the if it is a new building or a building under renovation, the aspects are same. You will follow the same guide. Okay. Only thing is when you are going for renovation, you will focus on energy efficiency more than materials. Like,
Eh,
uh, am I audible, sir?
अब तो हो गया.
Yeah, you're audible.
And I think
Anupama, now you try na for sharing the screen.
Yes, sir. Let me try.
यहाँ से नहीं हो रहा.
My screen is getting stuck, sir, when I'm trying to share.
Now we will try.
Yeah.
There is no any lock. Hello,
Is
Anupama.
it shared,
Yes.
sir?
Yes, yes, yes.
Okay. Uh, so this is an example building. So it is kind of confidential, but just for what you have asked, I'm showing you. It is a convention hall. Okay. They are renovating it, and then they have to achieve the green targets which are rated under IGBC and ECBC. So what they have done, instead of going for like what the material like the whole reconstruction, what they have done is whatever wall assembly they have just added a layer of insulation to the existing wall. Okay. And then comes energy efficiency. Instead of because the building was already designed, it's in place, we can't redesign with high ceilings or something now. So what they have done, whatever existing equipment is there, for example, I'll say the ACs and all, like HVACs and whatever lighting systems they have used, they have gone for uh, 3-star rating to 5-star rating. And then the glazing systems have the panels of the windows are changed. Only the glass panel is changed, the frame being same. So whatever little modifications you can do, maximum modifications will be through rating system. See, if I am using some sort of central AC system which is 3-star in my building, which is a convention hall, you imagine how much amount of energy I might need. I am changing everything to 5-star, that will eventually reduce and drop my electricity bill till 60%. So which is agreed and okayed by both IGBC and LEED. So you have to find out things what are like opportunities you are having in your existing building. And all lights are being replaced by LEDs. Just an example. And then cost analysis. This is very important. See, for all things which we have suggested for that renovation, uh, per base design, whatever it was previous design was 67 lakhs. But after redesigning and renovating, it became 1 crore 32 lakhs, which is like almost more than twice, because it's already existing building. Obviously it will cost more than a new building. So what we have considered is, if I am doing this by investing double of my amount, in how many years this extra 60 to 70 lakhs investment is gonna come back to me, which is called investment return. So in next maybe 4 to 5 years, I am able to cover this with whatever savings I have. Obviously client will go for it. So you have to prove that why and when do I recover from this.
so in that
Got.
in that last column, it's showing 65 lakhs something. So
Yes,
like it is a reduced cost. The last third one.
it's increased cost.
Okay.
Increased cost. This is like original as per whatever design they have built. It is only 67 lakhs it costed for them. But when we came into picture and changed everything, they are changing all type of air conditioners and all, right? So they have to invest 65 lakhs more to achieve certification. So it's
Oh,
double but worth it. So in 4 to 5 years they're going to get back their 65 lakhs. After 5 years the building will stay 50 years, 70 years, who knows. So after 5 years whatever they are getting is a benefit, right? So this is like thinking in long term and then achieving targets.
so we have just increased the sustainability of the building, right?
Exactly.
And yeah, one more thing. Also, we can have the carbon emission also reduced of this particular building in all aspect.
Carbon emissions, yes, of course. Why I say is for this particular project, I told you that we have switched all equipments from 3-star rated BEE to 5-star rated. So, how much carbon my 3-star AC is emitting? How much carbon my 5-star AC is emitting? So, it's almost half of it. Half of it be definitely reduced. So, obviously, my carbon emissions are getting down.
And also the ecological footprint will also be reduced over here.
Obviously. And also you will get an opportunity to control that microclimate of your entire building.
Okay.
Yeah.
So with this changes in the document within the report you are showing it to us, we
Yeah.
can apply for the certification of lead after this.
With the changes, but you can't send this document is for ECBC, particularly ECBC. This is the format. But when it comes to lead, it will already because it is like already very developed kind of tool. It already have list drop down of what credit. For suppose there is an option for energy compliance, you just have to select energy compliance and then select, oh yes, this is the proof I have that I have selected all my 3 star ACs and converted them to 5-star ACs. So you have to give them a proof, that's it. So like that you have to do for each and every credit. How much ever credits you may be able to do, that much higher rating you will get.
So we are basically dealing with the increasing the life expectancy of the building over here.
Exactly. Before doing all this, there should be a structured test that is aware that the how much time the building as a sustainable this thing like into sustainability and all. The first point and primary point of sustainability is not to build anything. Use whatever is already existing. So you're like there are a lot of technologies which come in to make the structure even more durable
Okay.
of for renovations. Yeah.
So we better focus on the renovation of a particularly already built building
Exactly. Instead of going for a new building.
instead of going. So basically we can have a approach of already developed building to be converted into energy efficient.
Exactly. That is like most preferable under all these rating systems.
Okay.
Yeah.
So apart from ECBC guidelines, do we have any other guidelines to be followed for the certification?
If you are, I have shown you that, right? Just a second.
Yeah.
If I go show you the slide, if you are like targeting what energy code, only energy things, then go for ECBC. But
Okay.
if you are focusing on government projects, do you know like all DMRC, Delhi Metro Corporation, these projects made IGBC as mandatory for all those projects, all their projects, all substations, all stations which are being designed from now on from DMRC is following IGBC. So maximum of government projects will go to IGBC. So
Okay.
yeah, if you're looking for higher range or something private, you can go for lead, Griha and all. So for each and every rating system, you will be having a guide available for free online. You don't have to pay for the guide. You have to go through the guide and then decide, okay, if this is working for me, then you have to register your project. While registering, you have to pay. That is how it starts.
Yeah, okay.
Yeah. And I guess if anyone have done the assignment, all are done with it.
Yeah, the time is over. Is anyone done with something? You can ask. So any calculation or anything have you done? You all three of you can. No, no. Wait, I'll tell her. Anupama, can you just stop sharing the document?
Yeah, before stopping, I just want to ask everyone to off this include surface resistance and give the value. Just off this and then give the value. And
Include that
this one,
surface.
off it. Yeah.
Okay.
Okay. I stopped sharing. Yes.
Include off the.
Off.
Now
Yeah.
now
Are coming one by one. Anupam.
Yes, sir.
Yes. Hello.
Hi.
So we had made the wall. So we had extruded polystyrene of 100 and then again plaster.
Mm-hmm.
So here we are getting meets most building codes as our answer.
Okay.
So the total thickness is 350. The U value is 0.284.
U value is 0.284.
Yes.
Okay. And
Uh,
where did you selected your site?
Yes.
Where is
It
your
is
site?
Noida.
Noida. It
Composite
comes
print.
under which composite? Okay. Your answer is 0.284, right?
U value, yes. Watt per meter square Kelvin.
Got it. For composite climate and your building type is?
Mixed use.
Sorry?
Commercial mixed use.
Commercial mixed use. Okay. I guess you have achieved a very good value, which can reach super ECBC certification for you. So you have
Okay.
chosen your materials wise, your view value is just perfect. So I'll
Okay.
share with you how much view values should be considered post this presentation. So you can just cross check whatever you have done is how much correct it is. Okay,
Okay.
great. Thank you.
Okay. Thank you.
Anyone else coming?
Hello.
Hi. Yeah.
So I had also done my dissertation on a similar topic. So I had taken a one-story building in Ludhiana, that is a residential building.
Hmm.
So there I had provided the main insulation I had provided in the ceiling to stop the solar heat intake.
Okay.
So I was asking, will this dissertation be able to help me further in this cohort, like in sustainability and climate action?
Of course, it will definitely help you because see, you hardly have three elements where insulation is important: walls, roof or ceiling, and then floors. So only three. So in that you are covering us the ceiling part, which is gonna be effective almost like 50% of your energy consumption inside your building. So this is going to be very important to you. Even every green rating system like LEED or IGBC, ECBC, everything have this aspect of insulation in roof, which comes under U values and V values. So it is very good topic. Please go ahead with that.
Okay, okay, thank you. So Anupma, we are hoping that other group will work. ये क्या होगा? Yeah, am I audible?
Yes, sir, you're audible.
Okay. So very wonderful session, and we are hoping that you want to show something.
Yes, sir. Because not much students have completed it, I will send this to Priya. So you can
Okay.
just give them whatever U values they got in composite climate that comes
Mhm.
under all building types. If their U value is under 0.4, they are good to go for ECBC complement building certification. If their U value is less than 0.4 and came to 0.34, they are
Mhm.
little higher stage, ECBC plus compliant. And now whosoever have given view value of 0.284, for suppose 0.22 and over it, they are good to go with super ECBC building, which is like highest level of accreditation. So I just want students to go through this and then see if what they have designed is aligning with the rating systems or not.
Okay.
Yeah.
Okay, Anupma. So thank you very much for the wonderful session, and we are hoping that whatever you have presented, that will be very advantageous for a student for generating and some other type of system. And you have also explained very nicely that in India, IGBC rating system, DIHA rating system, SOJAM rating system, and for global lead American rating system and WGBC, World Green Building Council system. Na? So thank you very much. We are hoping that rest student will contact with you, and all the best for your upcoming session in future. Thank you very much.
Thank you, sir.
Thank you.
Have a
Thank you,
good
Ji.
day. Thank you so much. Thank you, Priya.
Have a nice day and wonderful career ahead in upcoming time. Thank you. Big hand for Anupama Kuppam once again.
Thank you. Thanks a lot. Have a good day.